Bonjour à tous. I am Raudiere, chairwoman of the French telecommunication regulator, so-called Arcep, and I'm really pleased to be with you this morning to share Arcep's view on Internet of Things development. It is now obvious for everyone, especially after the various periods of lockdowns and travel restrictions due to the COVID crisis, that digitalization of our economy and of our everyday life is booming. It is also true that digital and telecommunication have made possible the resilience of our activities during this period. In this large picture, the Internet of Things is seen as playing an important role as of now and in the future. Connected sensors are already used by many industries or cities, enabling application in our everyday life. In smart cities with parking slot sensors that are so convenient to find an available parking space, or trash container level monitoring, and dozens of sensors for temperature, traffic, etc. In smart energy, with more and more remote metering and monitoring needs, it's smart manufacturing, where mobile robots will be often connected. It's smart building with smoke or water detector for safety usage, or connected heating or cooling equipment for remote control. It seems like all those industries become smart with IoT development. The Internet of Things is enabled by three important aspects. First, terminals, smartphones, and now mere objects like appliances or various home or industrial sensors are developing and producing tons of data daily for many usage. Second, the growth of data centers resources creates huge capacity for analytics. The artificial intelligence algorithm process more and more data, generally through dedicated Internet of Things platform. And third, the evolution of connectivity. Networks are no more providing connectivity for a device per person or per type of services, for instance, voice or internet access, but networks will be designed for a huge variety of connected objects with as much variety in services from few bits of data per day to large video monitoring file 24 hours a day. This is one of the promises of 5G networks. On one side, this network evolution is just as its early phases, and on the other side, the growth of connected objects has clearly been seen and observed. In France, during the last 6 years, we have observed an annual increase up to 80% of connected objects in the ISM band and of 13% of machine-to-machine SIM card object. As the French authority in charge of providing the spectrum resources for connectivity, Arcep is fully aware that it is a real challenge to make sure the connectivity part will cope with the required pace. Facing the challenge of connectivity, what are the solutions for IoT? What is Arcep's role? In the past few years, several technologies have emerged to provide such connectivity for IoT. Each of those has its own specificities, quite often tailored to answer specific usages and needs. Bluetooth or 6B, for instance, is used only for communication in a very short-range connection between an object to another device, often connected to Internet. This is, for instance, the case for smart watches, earphones, or some home appliances. Cellular connection using a SIM card is used for many applications, especially in mobility. This type of connectivity is about to evolve with the deployment of 5G networks and especially with 5G standalone. This new technology will allow a much larger number of objects to be connected simultaneously to the same antenna with very low latency and higher data throughput connection. This could, for instance, enable new usage like very flexible high-definition remote video monitoring. One may question the network power consumption growth caused by the future development of objects connected and the higher quality of connections. With a LoRaWAN, the object is connected to a dedicated IoT network. This type of connectivity is especially targeting objects and applications that have rather low data throughput need with low power consumption requirement. For instance, rain meter in outdoor, water consumption meter in buildings, parking slot sensors, pet trackers, all kinds of objects that are not easily connected to the power mains and with low frequency charging cycle. Each solution of connectivity is very complementary in order to address a great variety of object, usage, and connectivity needs. The first role of Arcep, and maybe the most known, is the mobile frequencies allocation. Arcep delivers licenses to the operator that commit in return to pay administrative fees and to fulfill various obligations. The regulator's objective is clearly that the public expectation of having a connection almost everywhere at an affordable price and the specific needs of industries are well considered by the operators. We have the authority to investigate and sanction to ensure that operators comply with their obligations. The role of Arcep is different for the frequency band used by LoRaWAN. We don't deliver individual license, but we make sure frequency bands are identified for this type of usage, and we set the rules to use those frequencies. In fact, LoRa communication technology is based on free-to-use frequency spectrum, the ISM band located between 863 MHz and 870 MHz in Europe, to be precise, and usually called the 868 MHz band. This frequency band is subject to a general authorization regime. This is commonly called an unlicensed band. As a consequence, anyone can develop a solution using this band to ensure data communication between a sensor and a remote application. Anyone can deploy a network using those frequencies without requesting a license. The only restriction concerns the intensity of its use by terminals, limited transmit power, and no more than 1% of the bandwidth is allowed to be used by a LoRa terminal at one time. Those constraints limit the amount of data that can be transmitted and the data exchange rate. Another specificity of this band is that it is not fully harmonized at the international level. ISM bands are not the same in all countries. A terminal configured on a frequency band will generally not work on other frequencies and therefore in other countries. This is, of course, a problem for LoRaWAN terminal suppliers that cannot rely on a large-scale volume market without a reconfiguration of the objects. This is a weakness compared to what is possible for cellular connectivity. Considering that the spectrum band needed to be increased in France to avoid or limit congestion in the actual 868 MHz band, shared also with Sigfox, Arcep decided 1 year ago to introduce new technical conditions that will enable the deployment of LoRaWAN networks in other bands. Those new ISM bands are common with the American ISM band and will allow terminals to be used in both regions without reconfiguration. This is an important step forward to decrease cost of LoRaWAN terminals and to speed up their worldwide deployment. Another issue for worldwide deployment is how to address the issues of interconnection between LoRa networks and roaming. LoRaWAN is not directly connected to the internet. When a terminal is connected to a network, it can only communicate through that dedicated network and be connected to specific application servers through the network server. LoRaWAN global network is hence composed by numerous public and private networks all around the world that are not by construction interconnected between each other. Nevertheless, initiatives exist to allow roaming between LoRa networks, such as Opgenius, which is a branch of Bouygues Telecom in France, and Proximus in Belgium, or between Orange in France and KPN in the Netherlands. But we are far from the beginning of a worldwide interoperability between LoRaWAN networks because the ISM bands are not harmonized yet between countries or continental regions. Beyond mere technology and frequency issues, the acceleration of IoT development raised some of the concerns in France, like everywhere in the world, which are topics for public debates: security issues, personal data protection issues, and environmental sustainability issues. In France, the authority in charge of network security aspect is the National Agency for Information System Security, and the authority in charge of personal data protection is the National Commission on Computing and Freedom, CNIL. This is not in Arcep's role. Therefore, I apologize, I won't address those two topics today. In contrary, at the end of last year, Arcep has been empowered by the law with a new role in developing a sustainable digitalization. Of course, the fight against climate change will not be possible without the development of digital technologies and connected objects that can provide solutions, for instance, in smart building and smart city projects. No one, especially not me, can deny it. But that does not exonerate the sector from the efforts to be made to limit its own impact on the environment. The actual carbon footprint of the digital sector represents 2.5% of the total in France, and this is 4% worldwide. This is already important, but above all, it is one of the sectors where the carbon footprint is growing the fastest. If nothing is done, the rate will rise from 2.5% to 7% of the total by 2040 in France. And in the digital sector, the terminal segments represent 80% of the total. As IoT could be one of the as IoT is part of the terminal segment, and certainly one part that is growing the fastest for the year to come in the industry, the impact of this growth on the environment is actually a focus of attention of Arcep. For instance, the International Energy Agency analyzed forecast up to 46 billion physical objects by 2030. What makes IoT critical from an environmental point of view, in addition to the growing number of projecting IoT devices, is that hardware profiles of such devices are heterogeneous, ranging from simple edge devices, for instance tags, low power and material frugal sensors, up to complex IoT devices with enhanced functionalities. I think of smart speakers, embedded devices with enhanced security features, or embedded AI. Such heterogeneity causes the study of its environmental impact especially difficult and complex. Today, there is a lack of life cycle assessment of IoT devices because the data is not always available and the measurement methodologies are various. This is also uncertainty on the lifespan of this device and its components, like batteries and other considerations, on how these objects are being deployed and used with a possible rebound effects. All these issues call to address the impact of IoT through a holistic and comprehensive view. By anticipating the impact from the design stage and by considering the impacts generated by IoT devices over the whole life cycle and not only at the device itself, but also at the system level wide. Coming up with a firm answer to all these questions is not an easy task. To illustrate such difficulty, one may raise methodological issues when dealing with the measurement of the impact of IoT. Should only the communication part of the device consider in the ISCT impact, or the entire device itself? How to count impact of LoRaWAN network server or application server that could be hosted in a multi-tenant data center? How to discriminate for which sector the impact will be accounted for, IST or the sector it is used for, like mobility sector in case of smart parking. This work has already been initiated by Arcep in collaboration with ADEME, the French agency in charge of ecological transition, with a group of telecommunication and environmental technical experts, and this will continue in order to provide Arcep and the entire community of interest as much as possible visibility to the whole sector on this important topic for the future. The work of this group aims at addressing the methodological gap while leveraging on existing works stemming from other international expert communities or standardization bodies like ITU. Once this first stage is solved, and it's not tomorrow, then it will be possible to build a comprehensive collection of metrics to monitor, to analyze them, and to report on the knowledge gained from them. By doing so, we will give users or companies the knowledge to choose the right solution regarding the sustainability impact. As a conclusion, I will say that some debates seem to be behind us. I remember with advent of 4G IoT that there were some voices to predict the end of IoT with unlicensed band like LoRaWAN. As a matter of fact, we can observe over the last few years that the growth of LoRaWAN IoT was faster than 4G IoT. No doubt, there will be in the future still room for this technology to be used for very low power, very low data intensive services. In addition, I'm convinced that when environmental impact will play a key role in deploying and developing new services, having a way to introduce robust services with device design for very low consumption and very long life duration will be a key point, will be very important for the choice of a solution. I see ISM band usage with LoRa technology as a good candidate to fulfill this role. I thank you.